Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about conditional probability. All right, so conditional probability is the probability of A given B equals the probability of A and B divided by the probability of B. So the probability of an event A given that we know that B happened. So we did already kind of look at conditional probability when we did the multiplication rule for dependent events, because dependent events have a conditional probability. Like the condition was that I took one card out first and now I have one less card. All right, so Legos. A 25 pack of Legos contains 2 yellow squares, 4 blue squares, 4 green squares, 3 yellow squares, 8 blue rectangles, 3 yellow rectangles, 8 blue rectangles, and 4 green rectangles. What is the probability of getting a blue? All right, well, I have 4 blue squares and 8 blue rectangles. And I have 25 Legos, so 4 plus 8 divided by 25 gives me 12 out of 25, which I could change to a decimal, which is 0.48. The probability of blue given a square is the probability of blue and a square divided by the probability of squares. Well, I have 4 blue squares out of 10 total squares. So 4 out of 10 would be 0.4. The next one, it says the probability of a square given it's blue. So this would be the probability of a square and blue divided by the probability of blue. Okay, so I'm just using my formula and replacing the letters A and B with S and B. And then putting them in the order everywhere an A was, I'm replacing it with an S. Everywhere a B was, I'm replacing it with a B. All right, so the probability of S and B, I have 4 blue squares divided by the probability of blue. I have 12 blues, so 4 out of 12 is 0.3 repeating. Probability of yellow, well, I have 2 yellow squares and 3 yellow rectangles. So I have 2 plus 3 out of 25 total Legos, so 5 out of 25 is 0.2 or 20%. The probability of yellow given it's a square. So this is the probability of yellow and a square divided by a square. So again, I'm replacing, in my formula, I'm replacing all the A's with Y's and replacing all the B's with S's. And then it kind of makes sense for my problem. So a yellow and a square, I have 2 yellow squares. Out of all of the squares, I have 10. So 2 out of 10 gives me 0.2. The probability of a yellow given it's a rectangle. So yellow and rectangle is equal to, I have 3 yellow rectangles out of 15 total rectangles, so 3 out of 15 is also 0.2. So I can see, because these all ended up being the same for the yellow and the type of Lego, whether it's a square or a rectangle, those are independent of each other. Okay. All right, tree diagram. A hospital is testing patients for a certain disease. If the patient has the disease, the test is designed to return a positive result. If the patient does not have the disease, the test should return a negative result. No test is perfect. 99% of patients who have the disease will test positive. 5% of patients who don't have the disease will also test positive. 10% of the population in question has the disease. If a random patient tests positive, what is the probability that they have the disease? All right, so I know that 10% of the population has the disease, which means 90% do not have the disease. So have the disease or don't have the disease. And then I'm going to also test everybody. So they're either going to test positive or negative. So if they have the disease, I know that 99% of patients who have the disease are going to be positive. So 0.99 for positive, which makes this 0.01 for negative of those that have the disease. And then 5% of patients who don't have the disease are going to test positive. So this is going to be 0.05, which makes this 0.95. And then with the tree diagram, I'm going to multiply across my branches. So 0.10 times 0.99 gives me 0.099. 0.10 times 0.01 gives me 0.001. 0.9 times 0.05 gives me 0.045, and 0.9 times 0.95 gives me 0.855. Okay, and you can check that last column there, and that should add up to 1. Also, each branch should be equal to 1, like each individual set of branches. All right, probability of D and positive. So the probability that the patient has the disease and tests positive. So they have the disease and they test positive would be going across that first branch, which is 0.099. The probability of a positive, I'm going to add my two positive test answers together. So 0.099 plus 0.045 gives me 0.144. And then the probability they have the disease given they test positive would be the probability they have the disease and test positive divided by the probability they test positive. So I already know the probability they have the disease and test positive is 0.099, and I just found the probability that they test positive was 0.144. When I divide those, I get 0.6875. All right, a two-way table. Researchers surveyed 100 students on which superpowers they would most like to have. This two-way table displays data from a sample of students who respond to the survey. So what's the probability that somebody would choose flying? All right, so for all the flying, we had 38 out of 100 students, so 0.38 or 38%. What's the probability that a student was male? Well, we had 48 males out of 100 students, so 0.48. What's the probability of a male given they choose flying? The probability somebody's a male given it was flying. So it's the probability of male and flying divided by the probability of flying. So we had 26 males choose flying out of 38 total for flying, which works out to 0.684. Then the other one, we flipped it around. What's the probability of flying given they're a male? So this is flying and male given male. So again, there's 26 males who chose flying, but this time it's out of 48 males. Okay, the conditional piece is always in the back, and it's always going to be the bottom of your fraction. All right, which is 0.542. All right, go Seahawks.